Hello, my name is Om, and for my level 4 chemistry project, I designed and tested a hand sanitizer to investigate how changing the alcohol concentration affects evaporation speed and its effectiveness. This demonstrates how chemistry is applied in the real world health products. So basically, the materials I used for this experiment is 99% isopropyl alcohol. Then I used the aloe vera gel. Then I also used this for measuring, a mixing bowl, like two mixing bowls for sample 1 and sample 2. Then I'm gonna use this plate for as a surface to test the evaporation speed. I'm also going to use this spray bottle to pour in the final solution. Okay, so for my pre-observation, I'm going to create a mixture with a higher concentration of alcohol using a 3 to 1 ratio of alcohol to aloe vera gel. This mixture has an approximate alcohol concentration of 74%, which is within the recommended range for effective hand sanitation. I'll repeat it 3 times. And then one more. Then I'm gonna use my aloe vera gel. And now we're gonna place this here and then close the lid. Then I will use this spoon to stir it. Until it fully, blends and stuff. Once it's roughly blended, I will place it on the surface, so the plate. Only a certain amount using this. Now I'm gonna set a timer to see how quickly it evaporates into the air. So as you can see, I've set a timer. I observed that this mixture evaporated in approximately 45 seconds. The faster evaporation is expected for high alcohol mixtures. To compare, I created a 1-to-1 mixture of alcohol and aloe gel. This lowers the alcohol concentration to about 50%, which is below the recommended 60% for effective sanitation. I included this as a comparison to show how changing the ratio affects evaporation and performance. So I'm gonna use this mixing bowl to see what happens and what's the evaporation speed. So I pour the alcohol. And I will also pour in an aloe vera gel now into the mixing bowl. Now I will close the lid here. Then let's check for this one. And when I'm done mixing it, I'm gonna place it there and mix it fully. I hope you could see that. Also, I forgot to mention one thing. You could put like some essential oil in it for fragrance, but I just wanted to create a basic hand sanitizer that's optional, so which is why you just used the aloe vera gel and the alcohol. I think it's roughly good. Now I will put this on the plate. Now I will set the timer once again. Now, as you can see, I've set a timer. I hope you could see that, but I can right now. Sorry, I know it's hard to see on the plate, but it's there. I'm constantly checking the timer. And so far it has been 56 seconds. So as you can basically see, I tested this mixture using the same method. This mixture evaporated more slowly, allowing it to stay on the surface longer. However, because the alcohol concentration is lower for this one, it is less effective at killing germs compared to the 3 to 1 mixture that I made previously, which is why I think that one was better. And I could still see some of the liquid, which means it has not evaporated into the air completely. I will wait for some more time to check when it is completely evaporated. It has been 2 minutes and 8 seconds, 9 seconds. You can clearly see on the stopwatch, and it has finally evaporated into the air now. And now I will put this into the spray bottle using the funnel. So as you can see, I transferred the improved 3 to 1 mixture into a spray bottle to demonstrate how it would be used in real life situations. Just for clarification, the green color of my final product comes from aloe vera gel and does not affect the effectiveness of sanitizer. This is normal and happens in many store-bought gels as well. Now I will test the final product onto my hands to see how quickly it evaporates, but it's still effective since it has, I think, about a 78% concentration in a 3 to 1 ratio. So I'll apply it again. I would like to mention that isopropyl alcohol is a volatile substance, meaning it evaporates quickly. However, if it evaporates too fast, it may not remain on the surface long enough to effectively kill germs. By adjusting the alcohol to alloy ratio, we can control how long the sanitizer stays on the surface while maintaining its effectiveness. According to a recent news article about unsafe hand sanitizers, using the correct type and concentration of alcohol is very important for both safety and effectiveness. This information influenced my design choices when creating my product. I also created molecular designs and named the compounds used, including isopropyl alcohol and water, which are included in my final presentation. The 1 to 1 ratio appeared smoother when poured, but its alcohol concentration is actually about 50%, making it less effective for sanitation. The 3 to 1 mixture contains about 74% alcohol and evaporates faster, making it more effective at killing germs. This demonstrates how changing the alcohol concentration improves the performance of the hand sanitizer and how chemistry can be applied to develop safe and effective real world solutions. Further, future improvements could include testing more precise alcohol concentrations to further optimize the product.